Now it is time for us to gather the metrics or efficiency of our merge-sort method so that we can fill out the worksheet. This process is somewhat more complex in this case because of the way this code is written. So what we're going to do is first go to the website and copy these 4 lines of code. These are some constant variables that we'll be able to use in our method to make this process easier, and then paste them in above the main method. Now, these constants consist of a string array that identifies what things we're going to be gathering, what information. In this case, the length of the array, the number of compares performed, and the swaps. And these labels are stored in a string array. Next, we have a constant variable that defines what label is stored in each position. So the array size is in element 0, compares is in element 1, and swaps is in element 2. Then, in our merge method, we're going to, or our merge sort method, we're going to change the return type from void to int array. And because it now has a return type, we're going to want to create a new integer array, which we'll call results, and we'll set it equal to a new int array. How many elements will be in this array? Well, we could just set it to 3, but if we want to make our program flexible for the future, say we wanted to add another metric later, if we make it equal to our MergeSort class dot results, result labels dot length, it will be set to 3 now, but if I were to go in and add a 4th metric, it would still automatically get included. The array size would change, and therefore there'd be room for the new item. Okay, this is referred to as robust code design. Next, we're going to fill our integer array with our initial values. So, our results of merge sort dot length, rather array size, is going to be equal to r dot length, and our results for our merge sort, our compares so far are 0, and finally our swaps are also 0. And then when we're done, we're going to return our results. Okay, the only problem is so far our compares and swaps are 0, and that's not terribly helpful because we of course know there will be some array swaps and compares performed. But where do they get performed? It turns out, of course, that they get performed in merge. Therefore, what we're going to need to do is to take this array and pass it into, or rather gather the results from the merge method, which means that the merge method now is also going to have to return an integer array. So once again, we're going to have a new int array, and we can just copy these lines here because we're doing the same thing. And the only difference is the length is actually the source array length. Okay, now when we return, we have to return the results here, and at the end of our method, we also have to return the results. Now all we have to do is actually fill the results in with some values. So, what values do we want to use? Well, first we need to figure out where we've done a compare. So, right here, we have performed a compare. So, we would say results compares plus plus. And at the same time, here we've done at least one swap. So we'll also increment our swaps. Then down below here, inside each of these while loops, we're performing a swap, but we're not performing a compare. Now when we return the results, they should have some valid numbers. The only problem is the way that we've written this, results is getting overwritten each time the merge method gets called, and what we want to do is have a running tally. So what we're going to do is the array size will never change, so we can leave that one alone, but we're going to need an integer called swaps and an integer called compares that we'll use for this outer method, and each time we get results back, we'll take our compares variable and we'll add to it results of our merge sort dot compares index. And then we'll do the same thing for our swaps so that that gets a running tally. And then once the loop here has completed, we'll copy those values. We're going to just reverse this process and say results of the merge sort for compares gets our compares value, and the results for our swaps will get our swaps variable. Now, when the method returns, we should be able to see how many swaps and compares and how long the array was. So let's see how that would work. First of all, let's check and make sure our program still works and that there are no errors. Whoops, didn't mean to run it in debug mode. Let's run it in normal. Try that again. Okay. Alright, so the program is still working. We haven't created any horrible errors. So now we can go back to our main method. Notice that we're calling merge sort, but we're ignoring the result right now. What we're going to want to do is have our int results array equal our merge sort, and then afterwards now we can output the results. And this is where this little structure that we set up here can save us some time, because we can write a loop that will loop through each of the values in our string array, our result labels dot length, and for each of these we'll output our merge sort dot result labels of I plus an equal sign plus our results of I. And if we've done this correctly, the first label will be length, and the first number that will get stored and returned in results should be the number of elements in our array. The second will be compares, and the third will be swaps. And here we go. We have a length of 16, 45 compares, and 64 swaps performed. Now we can change our integer array so that we can return only the elements that we want for a length that we want. So instead of giving our array this arbitrary length, we will set up a new int array, and let's create a new public static final int num elements equals 5. That will be how many elements we're going to put in our array. Equals keyword new int array. And then now we need to fill our array with values. Now, we had written some code to do this before, but since that code is not here, it will be good practice for you to go through and write that code. So, for int I equals 0, I is less than r dot length, I plus plus. We're going to iterate over the whole loop, and we're going to give r of I a value equal to, let's start by doing an array sorted by length, sorted in ascending order. So this would be data that's already in the proper order. 1, 2, 3, 4, 5 is our result, and 1, 2, 3, 4, 5 was exactly how our data started. Nevertheless, it had to perform 8 compares and 13 swaps in order to get our list unchanged, essentially. So, what happens if we change num elements to 10? We've doubled the size of our array. What happened to our swaps? Well, it went from, let's run this again. With 10 elements, it was 36. With 5 elements, it was 13. So it more than doubled. What happens if we go to 15? Look at our number of swaps. It's going up rapidly. But let's go back and look at our number of compares. So with a 5-element array, we get 8 compares. With a 10-element array, it only went up by 11. And then when we go to a 15-element array, it went up to 31. Notice that the number of compares actually went up by a lower value this time. So, now you have everything you need to fill out the chart. All you have to do is change the data that goes into the array to the best, worst, and random cases, and change the number of elements and write down your results.